FHIR is an acronym that stands for Fast Healthcare Interoperability Resources, nicknamed FHIR. FHIR is a new standard for exchanging electronic healthcare information and replaces the more rigid and complicated legacy formats. As patients visit various healthcare entities, clinics, imaging centers, laboratories, or even hospitals, there needs to be an easy and consistent way to share or transfer patient information from one location to the other. That's where FHIR comes in. FHIR is built on modern web technologies that are used by websites you visit every day, such as Twitter, Facebook, and Pinterest. FHIR's use of current technologies allows implementers to efficiently integrate, request, and transfer data between various healthcare systems. The basic building blocks of FHIR are called resources. Resources are broken down into distinct categories that can reference each other to form a more complete picture. Some examples of resources include clinical resources, such as allergies, medications, and care plans, identification resources that include patient, location of service, and device information, and financial resources that include billing, insurance coverage, and eligibility information. The FHIR specification defines the way resources can be exchanged between different systems, and each resource format is defined by the REST call for exchanging the data. The ultimate goal of FHIR is to solve a wide range of clinical and administrative healthcare problems by making healthcare information more portable and making interoperability better. To learn more about FHIR resources, check out the FHIR website at buildfhir.org.
Are you interested in using FHIR at your organization? Don't miss your opportunity to join us at the FHIR Connectathon, the only place where health IT vendors from across the marketplace get together to test and develop software using the latest FHIR specifications. To help you prepare for your first Connectathon, we have 2 insider tips for you. First, the availability of public test servers, and second, the fundamentals of searching FHIR. One of the things that makes FHIR so interoperable is its use of simple HTTP operations to get and store data on a server. Prior to attending a FHIR Connectathon, you'll want to become familiar with the way FHIR uses these operations. Fortunately, there are a number of public test servers for you to practice with before you arrive. They can be found under external links on the FHIR website. Searching for resources is fundamental to the mechanics of FHIR. Once you have your data search operations determined, you can traverse through, filter, or extract specific data based on the supplied parameters of the search.
The following are some examples of FHIR search strings. You can search for a patient using their patient ID, or their date of birth, or just their name. You can even search for observation values for an individual patient.
Next, we would like to show you a real example of how to connect up to a test server, search for a patient, and then extract patient-specific observations using QIE Standard, a free version of the Qvera interface engine.
In this example, the first thing we're going to look up is the patient's name and date of birth using just their patient ID number. Here we have a test patient with a patient ID of 104902. We are going to use that patient ID to perform a patient resource lookup on a public FHIR server to obtain the patient's name and date of birth. As we step the message through the channel, the first mapping function sets up our query. The second mapping function requests the patient information from the test server, and the third mapping function extracts out the patient's first name and last name and their date of birth. If we look at the results of the query, we can see the patient's information. In the second mapping node, we take the patient's name and ID from our first query and use them in an observation search parameter to request all the observations that reference the patient, Lewis Walker, on the FHIR test server. As we continue to process the message through, the first mapping function sets up the query and uses search parameters to retrieve all observations that reference our patient. The second mapping function requests the observations, and the third mapping function extracts out the returned observation values for the patient, Lewis Walker. Here we have extracted each individual observation value and placed them in our message cache for future use later in the channel. As you can see, FHIR holds many benefits over rigid legacy formats. We would like to leave you with one final thought of our experiences with the IHE FHIR Connectathon.